In this practical session, we are going to learn about the variables, how to read values into variable from the user, and during this course, we'll also learn about the various other aspects, whatever you have studied in the third session, like the keywords, the range of values, different data types available in C. All those things we'll see through the program. Right? Now, let's begin out here. Here, I've already written a very basic template with the header file and the main function. Now here I would like to store some value into a variable. As we have seen that whenever you want to work with the variables, you need to declare the variables, right? So while declaring the variables, you need to mention the data type. Okay, you have seen various data types like character, integers, float, double and all, right? So now let us say we would like to store a numeric value. The data type which is used to store a numeric value is integer. Let us try to create an integer variable. So first we mention the data type, which is int, and after that we mention the name. While naming the variable, we need to follow the guidelines whatever we studied, like it should begin with an alphabet, it should not begin with a digit, that's first thing. Then it should not be a keyword, right? And it should not contain any special characters, right? Now let me just say that I would like to just create a simple variable like num, and in that I want to store some value. If I want to store some value, I'll just write equal to 5. I've created a variable num, and in that I've stored the value. Now I want to print the value of this particular variable on the screen. So to print the values, we use printf. Okay. Now in the previous session, we have seen how do we print hello world, which was just a message. But here, if I just say something like num, which is same as variable name, what is the expected output? Will it print 5 or will it print num? Right? It will print num and it will not print the value of the variable. If you want to print the value of the variable, okay, what we should do it is, instead of using the variable name, right, we need to use something called as a format specifier, right? Okay, for every data type, we have one format specifier. The format specifier for printing numeric value, which is integer type, is %t, right? Now after this, we can just put a comma, but please do remember, within the double quotes, we need to specify the format specifier, or any other characters you want to print, you can always do that. Once you complete that, you need to put a comma operator. Then we need to specify the variable name, okay, whose value you need to print here. Like I want to print the value of num variable, right? Your program is done. Now let me try to run this particular program and show you the output. Let's click run out here. Let's see the output. Okay, the value is 5. Now no matter whatever the value you have stored here, the same value will be printed. Quite simple, right? Now the next thing is, I don't want to assign value directly here. Instead, I want to read value from the user. If you want to read value from the user, then we require another function. Okay, so before we could use that function, okay, when a program starts, we want to print some message on the screen so that the user can look at it and then he will enter the input. So I'll say enter a number, right? After seeing this message, the user will enter the input. Remember, this is simply a message which will be printed on the screen. After looking at the message, the user enters the input. And to read the input value, we use scanf, right? Again, we have to use the format specifier. Okay, since we want to read a numeric value which is integer, so we use %d, right? Okay, be careful that at the end, don't give any space here, don't give \n, right? Okay, at the beginning you can give a space, but don't give any space or a comma operator or a \n at the end in the scanf. Don't try to print any other message. Don't, okay, like for example, whatever I printed here, don't try to put the same thing in the scanf. Scanf, this should only contain the format specifier, right? After that, mentioning the variable in name is not sufficient. Instead, for the scanf, we need to specify the location where we need to store that scanned value. And how do we get the location? We need to use the address of operator. This address of operator will give me the location, okay, which is referred by the name num, right? So here it's going to read the value from the user and then it's going to place at that location. Once you, okay, fetch the value, then you can just use it for printing or any other calculations, right? Let me try to run this and demonstrate. Right, I want to enter the input like 34. Perfect. Okay, fine. Now we have worked with integers. We also have other data types. Like for example, let us say you want to work with fractional values. What is the data type for fractional values? It is float, right? And what is the format specifier for this? Percentage EF, right? The same way, percentage EF. In case if you use wrong format specifier, you will not see the correct output. Like if you use the wrong format specifier here, the input fails. If you use the wrong format specifier here, then it will not print the correct value. You should always use the correct format specifier. Clear? Okay, let us try to run this and we'll enter some fractional values. Okay, 34.78. Clear? Okay, now we could see that it is little bit not exactly as 34.78, it is near about 34.78 because internal while storing the floating point value there is some kind of approximation. Fine. Okay, this is clear, right? Now we had also studied about various data types and we have theoretically studied that what is the size of each of the data types. Now here we'll try to practically understand what is the size of each and every data type so that we can get confirmed message that okay, this is the size of the data type, right? So data types, what we have studied here is we have studied about character data type, okay, then we have studied about int, then we have studied about float, then we also studied about double, right? Okay, along with this you have also studied about short integer and long integer. Okay, right, I'll write short int, okay, I'll just write si, long int li. Yeah, we also studied about long double ld. I've declared this various variables and I want to know the size, the amount of memory reserved for each and every data type, right? If you want to know the data type of any variable, the language provides an operator called as size of. Clear? Okay, so we'll be using okay the size of, like for example, if you want to know the size of the character variable c, I can use size of c. Okay, what we have studied about size of character, it is 1 byte. Then okay, if I say size of I, it says it is okay. Remember we have studied that on a 16-bit machine it is 2 byte, on 32-bit machine it is 4 byte. All right, okay, let us also verify with the proof here. Our machine is 32-bit or a 16-bit. Fine, we'll try to understand that also, right? So I'd like to see size of float. What will be the size of float? We state that it is 4. Clear? Now I want to print this values. In order to print this values, I can print the message size of character equal to. What format specifier do I need to print? Should I use %c or should I use %d? Okay, we have supposed to use %d and not c because we want to print 1 on the screen and 1 is an integer value. We have to use %d. Clear? Okay, the same way if you want to print the size of integer, okay, what is size of integer? It is 2 or 4, right? Okay, we can just this. And size of float, we have seen it is, again, what should the format specify here? It should again be %d, or to be much more precise, it should be u because u stands for unsigned. Okay, unsigned in the sense it will only present positive values, no negative values, and the size of operator always gives you positive values. Fine, but %d is also okay, right? Now I would like to print this. Clear? Okay, the same way you can try it out with every other data type, right? Size of character is 1 byte, size of integer is 4 byte. From this we understood that we are not working with 16-bit, we are working with 32-bit. Okay, and also on 64-bit machine, size of integer is 4 byte only. Size of float is also 4 byte. Now on the same lines, we'll quickly try to do it for other data type. One for double, one for short integer, long double, right? So we'll try to do it for double, then short int, long int, right? Long double. Okay, this is my LD for long double, this is for long int LI, okay, this is for short int SI, and this is for D for double, right? Just read that double is 8 bytes, short integer is 2 bytes, long integer varies, right? We can observe what is the size of long integer in my machine. And long double also, there is no fixed size, it varies from compiler to compiler. So we are basically verifying it here. What is the size of long integer? Here size of long double is 12, long integer is 4, short integer is 2. And let me also tell you out here, size of long integer is not 4 in every machine, right? And every compiler. In some compilers you will get the size of long integer as 8. Is clear? Okay, fine. I hope till here everything is fine. And one more thing what you might have observed is all the keywords. What are the keywords we have studied out here? If you can just observe all the data types, whatever you use, character, short, int, double, short, right? Okay, the size of, they all are keywords, right? In the ID, you can just observe with the syntax highlighting, all the keywords are dark blue color. Clear? Okay. Now, from this itself, we can understand, okay, it is a keyword or not. You don't need to by heart all the 32 keywords which are present in C language, right? So one by one, as you, okay, in case if you want to create a variable, accidentally you end up using a keyword as a variable, right? While typing itself, we can get to know that it is a valid variable name or is it a keyword or not, right? Okay, that's one thing. And again, if you end up doing a mistake in the variable, like for example, let us say instead of C, I say 1C, right? The color is changed out there, right? Okay, now if you cannot even observe with the coloring there, but not a problem, if you try to build it, you will get an error. Okay, you will get an error. You can just observe here, you got an error here. Clear? So any mistake in variable names will be informed to you through the error message. Clear? Okay. And one point we should make a note is like whenever you declare a variable, make sure that the variable name reflects the kind of information you're storing in that. Fine. In the next programs, when we do some meaningful programs for solving various kind of problems, okay, we will always try to use meaningful names for the variables. Fine. Thank you.